The numbers refused to behave, and that was terrifying, because numbers are never supposed to lie. In a quiet laboratory at the University of Manchester in 1911, the air smelled faintly of metal and oil. Lamps hummed softly, glass instruments sat perfectly aligned. This was not a place for surprises. And yet, behind the glow of fluorescent screens and the patience of careful hands, something impossible was happening. Atoms were misbehaving. At the time, scientists believed atoms were gentle, diffuse things, soft spheres of positive matter with tiny electrons sprinkled inside, like raisins in a pudding. It was a comforting idea, simple, predictable, safe. And Ernest Rutherford trusted it enough to test it, not to break it. The experiment was supposed to be routine. Fire a stream of tiny alpha particles at an impossibly thin sheet of gold foil. Most particles should pass straight through. A few might drift slightly. Nothing dramatic. So when the data first came in, no one panicked. Then more data arrived, and more. Some particles weren't just deflecting, they were bouncing back, hard, as if they had struck something dense, something solid, something massive. Rutherford stared at the results, replaying them again and again. This wasn't a rounding error. This wasn't faulty equipment. The experiment had been repeated, checked, verified. The numbers were stubborn, relentless. Midway through the analysis, a quiet question began to echo through the lab. What if the model is wrong? Imagine firing a bullet at tissue paper and watching it ricochet straight back at your face. That was the moment the room changed. The comforting picture of the atom shattered. Because for those particles to rebound, the atom couldn't be soft and spread out. It had to be mostly empty space, with a tiny core so dense it could turn incoming matter around. A nucleus. Small. Violent, powerful. The realization landed with the force of the very particles they had launched. Nearly all the atom's mass was crammed into a minuscule center, while electrons circled far away, suspended in vast emptiness. The world once thought solid was suddenly revealed to be mostly void. Rutherford later said it was the most incredible event of his scientific life, not because it confirmed a theory, but because it destroyed one. And that destruction changed everything. Modern chemistry, nuclear physics, quantum theory, the technologies shaping your life today, all trace back to a moment when the data refused to obey. Because science doesn't advance when we're right. It advances when reality pushes back. If this story made you see the world differently, take a moment to like, share, subscribe, and leave a comment. Your support helps this channel keep uncovering the moments that changed everything.